In this problem, we are given that there are n packets that arrive, no packets are currently on the line, so there's no starting queuing delay, and each packet is L long and transmitted at a rate of R. The question is to find the average queuing delay, so we're just going to first by just finding how long the first packet will be, which is going to be 0 as there's nothing else on the line, but we know it'll take L over R time to send that one, so we know the second one will have a queuing delay of L over R as it has to wait for that first packet. So then the second one will have a queuing delay of 2 L over R as it has to wait for that first packet and that second packet. But you can then expand that out to n, and you end up with n minus 1 times L over R. But it's n minus 1 instead of n because the first one had 0 queuing delay, so you don't have to include that one's extra queuing delay. And since we're calculating the queuing delay average, you end up with 0 for the first one, plus L over R for the second, plus 2L over R for the next, so on until you get the n minus 1 L over R. And then you add all that together and divide by however many, which is n. And then simplifying, you can divide out L over R as it's in every number here except for the 0, but 0 doesn't matter. So you end up with L over Rn times the sum between 1 and n minus 1. And using other math, we know that sum can be simplified down to the first number plus the last number times however many divided by 2. So then that would end up with our n minus 1 times n over 2 over here, which we can then sub in for the sum of the numbers. So then you end up with L over Rn times n minus 1 over 2, which, since this is just fraction multiplication, you can just multiply it across. And once you multiply it, you can see that there's 2 loose ends that you can then just cancel out. So then you ended up in the end with L times n minus 1 over 2R.